Welcome to the peaceful space of sleep-friendly science, where tonight we journey through billions of years to witness the quiet, cosmic destiny of our very own star, the Sun. As you begin to unwind, let your curiosity gently drift towards the heavens. We will travel forward in time, exploring the profound, slow transformation of our Sun and pondering the ultimate fate that awaits our small, blue world in its final, glowing embrace. Let your mind float on these cosmic questions. Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1, Our Sun, the Constant Gardener. As you lie here, resting, feel the faint, residual memory of daylight. Perhaps it is the lingering warmth in the room, or the soft, silver light of the moon outside your window, a light that is only a gentle reflection, a whispered echo of the sun's own brilliant voice. We think of the sun as a given, a constant fixture in our sky, as reliable as the ground beneath our feet. It rises, it sets, it warms our world. It asks for nothing in return. It is the silent, beating heart of our solar system, and for the whole of human history, it has been utterly dependable. Tonight, let us begin our journey by paying respect to this magnificent constancy. Imagine the sun not merely as a distant, fiery ball of gas, but as a patient cosmic gardener. For 4.5 billion years, this gardener has tended to its small, blue-green patch of the universe. Its primary tool is light, and it scatters this light with unimaginable generosity. Each photon that leaves its surface is a seed of energy, traveling across the void to fall upon the earth. These seeds warm the soil of our continents, stir the waters of our oceans, and feed the leaves of every plant, forming the very foundation of the world you know. This gardener works to a rhythm of profound stability. It has a schedule it has kept for eons, a consistency that has allowed life to take root, to hold on, and to flourish in the most spectacular ways. The gentle, predictable tilt of our planet as it orbits the sun is what creates our seasons, the slow, deep breath of the world. The sun's light dictates the cycles of waking and sleeping, of growth and dormancy. It is the grand conductor of Earth's orchestra, and its music is the symphony of life itself. This period of steadfast reliability has a name in the language of astronomy. The sun is a main sequence star. This is not just a label. It is a description of a state of being, a long and peaceful adulthood for a star of its kind. Think of it as a state of perfect cosmic equilibrium. Deep within the sun's core, two colossal forces are locked in an eternal, silent dance. One is gravity, the immense weight of the star itself, a relentless pressure trying to crush everything inward towards the center. It is an invisible force of immense power, pulling, squeezing, compacting. But resisting this crush is an equally powerful force, pushing outward. This is the energy born from the sun's very heart, its nuclear furnace. In the core, the pressure and temperature are so extreme that they defy all earthly comparison. Here, in this crucible, the most fundamental element of the universe, hydrogen, is being forged into something new. Individual protons, the hearts of hydrogen atoms, are squeezed together with such violence that they overcome their natural repulsion and fuse. They merge, they transform, and in this act of cosmic alchemy, they become helium. This process, nuclear fusion, is the secret to the gardener's strength. And here is the most poetic part of the physics. When 4 hydrogen atoms are fused into one helium atom, the resulting helium atom weighs just a tiny fraction less than the 4 hydrogen atoms that created it. That minuscule amount of lost mass does not simply vanish. It is converted, in a flash of brilliance described by the most famous equation in science, into a tremendous burst of pure energy, into light and into heat. This conversion happens billions upon billions of times every second, inside the sun's core. It is a continuous, self-sustaining React-Iona star's slow, steady heartbeat. This outward-pushing energy, born from annihilated matter, perfectly balances gravity's inward pull. This is the great piece of the main sequence. The star is not collapsing, nor is it flying apart. It is stable. It is in its prime. It is our sun as we know it and love it. For as long as there is enough hydrogen in its core to fuel this furnace, the gardener will continue its work, calmly and without fail. Let your mind drift now, and imagine the journey of a single particle of that light, a photon born in that chaotic core. It does not travel straight to us. Its journey is far more ancient and meandering than the 8 short minutes it takes to cross the space between the sun and the earth. Once created, this photon begins a journey not of seconds, but of millennia. It is born into a region of the sun so dense it is like nothing you can imagine. The photon travels only a microscopic distance before it is absorbed by another particle, held for a moment, and then re-emitted in a random new direction. It stumbles through this dense plasma in a great cosmic game of pinball, a drunkard's walk that can last, on average, for over 100,000 years. Think of that. The light that warmed your face today may have been born in the sun's core before modern humans ever walked the earth. For 100,000 years, it wandered, lost within the star that created it. Eventually, after its long, slow pilgrimage through this dense radiative zone, the photon reaches the sun's next layer. This is the convective zone, a vast, churning ocean of hot gas. Here, things are different. The energy is carried not by wandering photons, but by great, boiling currents of plasma. Hotter material from below rises, carrying our photon with it, much like a bubble rising in a pot of boiling water. It cools as it reaches the surface, releases its energy and its passenger photon, and then sinks again. Our photon has finally hitched a fast ride to the surface. And then freedom. It bursts forth from the photosphere, the visible surface of the sun that we see, and begins its final, uninterrupted sprint across the 93 million miles of space to Earth. 8 minutes. A mere 8 minutes after a journey that lasted for 100 millennia. It completes its epic voyage, perhaps by landing on a leaf, or warming a patch of ocean, or coming to rest upon your closed eyelid as you doze in a sunbeam. Every ray of sunlight that touches our world is an ancient traveler, a messenger from the sun's deep past, carrying the energy that makes our present possible. This stability extends beyond just light and heat. The sun's immense gravity, that other half of the great balancing act, is the anchor for our entire solar system. It is a quiet, invisible hand that holds every planet, from Mercury to Neptune, in its precise and graceful orbit. It dictates the silent, cosmic ballet that has been performed without interruption for billions of years. Earth is held at just the right distance, not too close to be scorched, not too far to be frozen. This region, the Goldilocks zone, is the temperate ring around the star where liquid water can exist. It is the garden bed, perfectly placed before the gardener's light. So as you rest here, in the quiet of the night, feel the stability of this moment. The world is turning. The sun, on the other side of the planet, is patiently waiting. This heart is beating with the fire of fusion. This gravity is holding us in a secure embrace. It is the constant, the provider, the anchor. It feels eternal. From the perspective of a single human life, it is. But in cosmic time, in the deep, slow time of the stars, even the most patient gardener must eventually see the seasons change. The sun is middle-aged, burning through its vast reserves of hydrogen fuel. But the fuel is finite. The garden is in its long, glorious summer, but even the longest summer must eventually give way to autumn. The changes are coming, but they are so slow, so gradual, that they are imperceptible to us now. They are written in the language of physics, a future story we can read, a destiny that awaits our star, and the small, blue world that orbits it. Section 2. A slow, gathering light. The sun's long, peaceful summer does not end in a sudden frost. It does not turn to autumn overnight. The change is far more subtle, a transformation happening on a timescale so vast it is almost impossible for a human mind to truly hold. It begins not with a dimming, but with a brightening, a slow, gathering light. As you rest now, imagine this change, not as a flash, but as the quiet, incremental turn of a cosmic dial, a dial that cannot be turned back. This process began the moment the sun was born, and it is happening even now as you listen. Remember the delicate balance in the sun's core, the outward push of fusion against the inward pull of gravity. As the sun continues its main sequence life, the hydrogen in its core is steadily converted into helium. This helium, the byproduct of the sun's fire, is like a fine, heavy ash settling in the heart of the furnace. Helium is denser than the hydrogen that surrounds it, so this helium ash sinks, accumulating in the very center of the core. As this dense helium core grows, its gravitational pull increases. It gently, but relentlessly, squeezes the surrounding shell of hydrogen fuel. It is like stoking a fire by compressing its embers. This increased pressure and density raises the core's temperature, and a hotter core forces the rate of hydrogen fusion to accelerate. The sun's furnace begins to burn hotter, not because it is aging and weakening, but because its own byproducts are causing it to work harder. It is a feedback loop written into the laws of stellar physics. The result is that our sun is slowly, almost imperceptibly, becoming more luminous. For every 100 million years that pass, the sun's energy output increases by about 1%. 1%. It sounds like almost nothing, a statistical rounding error, a change so small you would never notice it in your lifetime or in 1,000 lifetimes. But our journey is one of deep time, where tiny changes, given millions upon millions of years, can accumulate to reshape worlds. These small whispers of change, compounded over eons, will eventually become a roar. Let us drift forward in time, just a few 100 million years from now. The Earth will still look much like the world we know. The continents will have shifted, of course, drifting into new, unfamiliar patterns. But there will still be blue oceans, white clouds, and green land. To a visitor from our time, it would seem familiar. Yet something would feel different. The air would feel heavier, the heat more persistent. The global average temperature would have risen. The great ice sheets of Antarctica and Greenland, those ancient, frozen titans of our world, would be long gone, their waters having been added to the seas. The coastlines you know would be submerged, ancient cities turned into modern reefs. For a time, the Earth will fight back. Our planet is not a passive victim. It is a complex, dynamic system with its own ways of regulating its temperature. It has a planetary thermostat, a beautiful, self-correcting mechanism known as the carbonate-silicate cycle. It works like this. The sun's increasing energy heats the planet, causing more water to evaporate from the oceans. This leads to more moisture in the atmosphere, more clouds, and more rainfall. This rain, falling through the air, absorbs carbon dioxide, becoming slightly acidic, like a weak soda water. When this carbonic acid rain falls upon the land, it weathers the silicate rocks of our continents. It chemically breaks them down, releasing calcium and other minerals. Rivers then carry these dissolved minerals down to the sea. In the ocean, microscopic organisms use these ingredients, along with the dissolved carbon dioxide, to build their tiny shells of calcium carbonate. When these organisms die, their shells drift down to the ocean floor, settling in thick layers. Over geological time, This process locks away vast quantities of carbon dioxide from the atmosphere, turning it into limestone rock. It is the Earth, in essence, taking a deep breath and burying the heat-trapping gas in its own crust. A hotter sun means more rain, which means faster rock weathering, which means more carbon dioxide is pulled from the atmosphere. This creates a cooling effect, counteracting the sun's increased brightness. For hundreds of millions of years, this elegant dance will continue. The Earth will adjust its thermostat, maintaining a delicate balance where life can still survive. But a thermostat can only be pushed so far. The planet's attempts to save itself will eventually sow the seeds of a new kind of decline. Drift forward now, perhaps 600 to 800 million years into the future. The sun is now significantly brighter, its light more intense, more demanding. The Earth's thermostat is working overtime. The process of pulling carbon dioxide from the atmosphere has become so efficient, so relentless, that the concentration of this vital gas begins to fall to dangerously low levels. And here lies the great, tragic irony of Earth's deep future. Carbon dioxide is not just a greenhouse gas. It is the fundamental food for almost all plant life. Plants breathe it in, using the energy of sunlight to convert it into the sugars and tissues that form the base of nearly every food chain on the planet. As the Earth desperately cools itself by scrubbing the sky of CO2, it will begin to starve its own biosphere. The decline will be slow, a creeping famine measured in millennia. First, the most complex plants, the great forests and lush jungles, will begin to struggle. They require higher concentrations of CO2 to thrive. They will thin out, their ranges shrinking. The world will start to lose its vibrant green color. Grasslands might fare better for a time, as grasses are more efficient at capturing scarce CO2, but even they will eventually reach their limit. The great oxygen-producing engines of the planet will begin to sputter and fail. As the plants die off, the animals that depend on them will follow. The entire intricate web of life, woven over billions of years, will begin to unravel, strand by strand. The amount of oxygen in the atmosphere will slowly decrease. The world will become browner, more barren. Life will retreat to the last holdouts, perhaps to cooler, higher altitudes or to microbial mats in sheltered bodies of water. But the trend is irreversible. The gardener's light has become too harsh, and in its attempt to shield itself from the heat, the garden has inadvertently been deprived of the very air it needs to breathe. Imagine standing on this future Earth. The sun in the sky would look much the same as it does today, perhaps a little larger, a little more white in its glare. But the world around you would be alien. The air would feel thin and strange. The landscape would be stark, dominated by rock and sand, the ghosts of ancient soils, the vibrant sounds of a living planet, the birdsong, the insect buzz, the rustle of leaves would be replaced by the lonely sound of the wind sweeping over a dying world. The oceans would still be there, vast and blue, but they would be growing warmer. A slow, planetary fever is setting in, and there is no cure. The Earth's thermostat is broken. It has run out of CO2 to remove from the sky. From this point on, there is nothing left to counteract the sun's ever-increasing luminosity. The temperature will now rise unchecked. The planet is being pushed towards a tipping point, a threshold beyond which there is no return. As we end this part of our journey, let us rest in this solemn, quiet space. A world, once teeming with life, is being slowly, inexorably sterilized by the same star that gave it birth. It is not a death of violence or sudden impact, but a slow, quiet fading, a planetary system following the unchangeable laws of physics. The gathering light has done its work. The long summer is over. A new, far more terrifying season is about to begin. The Earth is on the brink of a fever dream, from which it will never awaken. Section 3, Earth's Fever Dream. The air is still. The final, faint whispers of life have long since vanished, and the world is now a silent museum of rock and dust, orbiting a star that is growing ever more powerful. We are now 1 billion years from home from our time. The sun, now 10% more luminous than the one you know, hangs in the sky, no longer a friendly golden orb, but a brilliant, white-hot spotlight. The tipping point has been reached. The Earth's long fever is about to break, and it will descend into a dream from which there is no recovery. Let your mind drift down to the surface of this future Earth. The great oceans are still here, a vast expanse of liquid water, but they are not the cool, life-giving seas of our time. They are eerily placid and unnaturally warm, like a bath left to heat for too long. A strange, shimmering haze hangs over the water, the air thick with a humidity that would be instantly suffocating. The atmospheric thermostat is broken, and the planet's last great defense mechanism is about to turn against it in a spectacular and final betrayal. This mechanism is water itself. In our time, water vapor is a vital part of the Earth's warmth, a gentle blanket. But now, the blanket becomes a smothering shroud. As the sun's intense radiation beats down, the surface of the oceans warms, causing more water to evaporate. This water vapor, a potent greenhouse gas, rises into the atmosphere, trapping more of the sun's heat. This trapped heat warms the oceans even further, which in turn forces even more water to evaporate. It is a vicious, accelerating cycle, a runaway feedback loop, a planetary fever spiraling out of control. This is the beginning of the runaway greenhouse effect. Imagine the sky. It is no longer the familiar, friendly blue. The blue color of our sky is the result of light scattering off molecules of nitrogen and oxygen. But now, the atmosphere is becoming so saturated with water vapor that the sky itself begins to change. It becomes a pale, milky white, a luminous, oppressive dome of steam. The distinction between cloud and sky dissolves, leaving only a featureless, glaring canopy that traps heat with terrifying efficiency. The temperature on the surface begins to climb, past any point life could endure. First to 40 degrees Celsius, then 60, then 80. The world is becoming a planetary-scale steam room. The oceans do not boil in the way you might imagine a pot on a stove, with frantic bubbles rising from the bottom. Instead, they begin to boil from the top down. The sun's energy, unable to penetrate deep into the water, superheats the surface layer, which flashes into immense clouds of steam, rising to join the suffocating atmosphere. The sound of this world would be a constant, deafening hiss, the sound of an entire ocean turning to gas. The pressure at the surface begins to build, the weight of a waterlogged sky becoming immense, crushing. This process, once started, is astonishingly fast in geological terms. Over a few million years, a mere blink of an eye in the life of a planet, the entirety of Earth's oceans will evaporate. All the water that carved the Grand Canyon, that filled the Pacific Trench, that sustained every living thing for billions of years, all of it will be lifted into the atmosphere. The Earth will become a steamy, high-pressure world, its surface temperature now soaring to hundreds of degrees, hot enough to melt lead. The ground itself, the ancient sea floors, now exposed to this incredible heat and pressure for the first time, will glow a dull, angry red. You are a silent observer, watching this final, terrible transformation. The Earth, our beautiful blue marble, is gone. In its place is a featureless, shrouded orb, a failed twin of the planet Venus. But the water is not safe even in the sky. Its final destruction is about to take place in the upper reaches of the atmosphere. Here, high above the dense steam clouds, the sun's radiation is even more ferocious. The powerful ultraviolet rays, the same rays our ozone layer protects us from, now strike the top of this steam-filled atmosphere with impunity. These high-energy photons act like tiny, tireless scissors, snipping the bonds that hold water molecules together. They find the H2O and break it apart. Photodissociation, the scientists call it, a gentle name for the dismemberment of water. The molecule is split into its constituent parts, 2 atoms of hydrogen and 1 atom of oxygen. The oxygen, being heavier, tends to linger in the atmosphere, where it will eventually react with the hot rocks below, rusting the entire planet on a global scale. It will turn the world a deep, desolate red-brown. But the hydrogen, the lightest of all elements, meets a different fate. Once freed from the water molecule, these tiny atoms are so light that Earth's gravity can no longer hold on to them. They drift upward to the very edge of the atmosphere, and then, one by one, they escape. They bleed away into space, a silent, invisible river of hydrogen flowing out of the world, lost to the solar wind forever. It is the planet's lifeblood, its very essence, irrevocably draining away into the void. This process continues relentlessly for hundreds of millions of years. Every drop of Earth's ancient water is hoisted into the sky, torn apart by sunlight, and its hydrogen is cast into space. The planet becomes a monument to water, a world whose entire geology and atmosphere are shaped by the memory of oceans that no longer exist. It is now a bone-dry, sterile, furnace-hot rock, with a thick, crushing atmosphere of carbon dioxide and nitrogen. The fever dream is over. The patient has not recovered. It lies still, a baked and rusted husk, circling the star that has become its executioner. It is a dead world, utterly, completely, and permanently. And yet, its journey is not over. It is still a planet, held in its familiar orbit by the sun's unwavering gravity. It is now a silent, scorched witness, waiting for the sun's own great transformation, a change that will make the Earth's fever dream look like a gentle slumber. The sun's core is continuing its slow, inexorable change. The gardener is about to put down its tools and begin to swell, to reach out with arms of fire. The great expansion is about to begin. Section 4. The Great Expansion begins. For 1 billion years, you have been a silent witness to Earth's slow desiccation, watching from afar as it was rendered sterile by a star entering the prime of its middle age. Now, the Earth is but a scorched, silent spectator to a far grander drama. The sun itself is about to undergo a transformation so profound it will redefine the architecture of our entire solar system. The long, stable summer of its main sequence life is officially over. The great expansion is about to begin. This monumental change begins not with a bang, but with a quiet, final flicker in the sun's deepest heart. Let your mind drift back to that core, which for 5 billion years has been a furious engine of hydrogen fusion. It is no longer. The hydrogen fuel in the very center has now been exhausted. The last few atoms have been forced together, their transformation into helium marking the end of an era. The furnace at the very heart of the sun has gone out. For the first time in its life, the core is inert. It is a dense, dead sphere of helium ash, producing no energy of its own. Remember the eternal dance between gravity and the outward pressure of fusion. With one partner suddenly gone, the dance is over. Gravity, the patient, relentless force, finally claims its victory. The helium core, with nothing to hold it up, begins to collapse under its own colossal weight. Imagine a sphere 1/3 of the mass of the sun, squeezing itself smaller and smaller. This is not a violent, instantaneous implosion, but a slow, powerful contraction. As the core shrinks, the pressure within it skyrockets, and its temperature soars to unimaginable heights far hotter than it ever was during its hydrogen-burning phase. The dead heart of the sun is becoming a white-hot cinder, heating up as it collapses. This intense heat cannot be contained. It radiates outward from the inert core into the layers of the sun that still surround it. It floods into a thick shell of hydrogen that has, until now, been just outside the main fusion zone, like unused fuel still in the tank. This shell of pristine hydrogen now finds itself pressed against a ferociously hot, collapsing core. The temperature in this shell climbs, reaching the critical point for fusion. And so the fire is reignited. But this is a new kind of fire. It is not the steady, gentle flame in the center of the star, but a raging, desperate inferno in a shell surrounding a dead heart. This is hydrogen shell burning. This new furnace burns with a ferocity the sun has never known. The fusion rate is orders of magnitude higher than it was during the main sequence. An immense, overwhelming torrent of energy is now being unleashed, not from the center, but from a ring of fire deep within the sun. This furious outward push of energy completely overwhelms the sun's gravity. The star, which has maintained its size and shape for billions of years, can no longer hold itself together in the same way. It has lost its equilibrium. In response to this incredible new wave of energy from within, the sun's outer layers begin to do the only thing they can. They expand. It begins as a slow, majestic swelling. Think of it as the sun taking a deep, slow breath that will last for hundreds of millions of years. It is a quiet, inexorable process of unfurling. The surface of the sun, the photosphere, begins to push outward, moving away from the core, swallowing the space around it. Millimeter by millimeter, kilometer by kilometer, the sun grows. As you float here in the darkness, watching this cosmic spectacle, you see the sun begin to change. The process is slow, but its effects are monumental. The star that was once a brilliant, distant point of light is now visibly, undeniably growing larger in the sky of the dead Earth. This expansion brings with it a strange and beautiful paradox. The sun's furnace is burning hotter and more furiously than ever before, releasing vastly more energy into the solar system. The star is becoming incredibly luminous, and yet its surface begins to cool down. This happens because the same amount of energy is being spread out over a vastly larger surface area. It is like the difference between the focused heat of a welding torch and the gentler, radiant warmth of a giant bonfire. The total heat is far greater, but the temperature at any given point on the surface is lower. As the surface cools, the light it emits changes color. It shifts from a brilliant white-hot glare to a softer, yellower hue, then to a warm orange, and finally, to a deep, ominous, and beautiful red. The sun is transforming into what astronomers call a red giant. It is a name that is both simple and perfectly descriptive. A giant and red. Imagine the sky as seen from the barren rock that was once Earth. The sun, which for eons had occupied a tiny patch of the sky, now begins to dominate it. It swells, growing from a small circle to a noticeable disk, and then to a huge, looming orb that fills a significant portion of the heavens. It is no longer a star in the sky. It is the sky. The light it casts upon the rust-colored plains of Earth is not the harsh white of the fevered dream, but a deep, perpetual blood-orange twilight. The total energy reaching Earth is now immense. Any last vestige of atmosphere is stripped away by the strengthening solar wind, a stream of particles flowing from the expanding star. The surface of the Earth, already baked and sterile, is heated further still. The rock itself begins to glow with its own faint, cherry-red heat, reflecting the color of the monstrous star that now looms over it. The Earth becomes a furnace, mirroring the furnace in the sky. This is the subgiant phase, the prelude to the main event. The sun will continue this expansion for millions of years, its outer layers reaching further and further into the void. It is a star entering a new and final stage of its life, a stage of immense scale and grandeur. It is no longer a gentle gardener. It has become a cosmic titan, stretching its fiery limbs, reaching out across the space it has ruled for so long. And in the path of this expansion lie the inner planets, the sun's closest children. They have held their orbits faithfully for billions of years, but their parent star is now swelling to meet them, preparing a fiery, final embrace. The quiet dance of gravity is about to be overwhelmed by a slow, silent, all-consuming tide of fire. Section 5. A fiery, final embrace. The sun's expansion is no longer a subtle prediction. It is the overwhelming reality of the solar system. The star, our star, has become a celestial entity of impossible scale, a slow-motion catastrophe blossoming from the heart of our cosmic home. Imagine this red giant not as a solid object, but as a vast, tenuous ocean of incandescent gas, its edges diffuse and uncertain, like a fog made of fire. Its surface is a churning, convective sea of plasma, great bubbles of superheated gas, each the size of a continent, rising and falling in a slow, hypnotic rhythm. The star is breathing, and with each breath, its atmosphere creeps further into the void. The first to receive this fiery embrace is Mercury. For billions of years, it has been the sun's closest companion, a tiny, scarred world baked by relentless radiation. Its fate was sealed from the beginning. As you watch, a silent observer in the timeless dark, you see the outermost wisps of the sun's atmosphere, its chromosphere, begin to touch the orbit of this little planet. At first, it is nothing more than a ghost of contact, a few stray atoms of solar gas brushing against the planet's ancient rock. But the tide of fire is relentless. Mercury's journey, once a stable, predictable loop, now becomes a final, silent pilgrimage. It begins to skim through the upper layers of the star itself. The drag is immense. It is like trying to run through water. The planet's orbital energy is stripped away with every passing moment, and its path begins to decay. It spirals inward, faster and faster, descending into the denser, hotter layers of its parent star. The end is not an explosion. It is a dissolution. The incredible heat first melts the planet's surface, turning its rocky crust into a teardrop of glowing lava. Then, as it sinks deeper into the furnace, the rock itself begins to boil, to vaporize. The planet bleeds its substance away, atom by atom, into the surrounding plasma. It dissolves like a sugar cube in hot tea. In a final, silent flash, the last remnants of the planet that was Mercury are gone, its constituent atoms now indistinguishable from the atoms of the sun. It has returned to the star from which its dust first condensed. A world has been unmade, absorbed back into its creator. Next, the fiery tide swells outward toward Venus, Earth's twin. A world already lost to its own hellish greenhouse effect has been orbiting in this orange twilight for millions of years. Its thick, toxic atmosphere has long since been stripped away by the sun's intensifying solar wind. It is a naked, scarred rock, waiting. The leading edge of the red giant sun now reaches the orbit of Venus. The process repeats itself, but on a grander scale. The second planet from the sun begins to feel the drag of that tenuous stellar atmosphere. Its orbit, too, begins to decay. It fights for a time, its immense momentum carrying it on its path, but the battle is hopeless. It spirals down, a moth drawn to a flame that now fills half the sky. Venus, the planet named for the goddess of love and beauty, follows Mercury into the fire. It melts, boils, and vaporizes, its material legacy given back to the star. The inner court of the solar system is being cleared, one world at a time. And now there is Earth, our Earth, a dry, red, hot, and empty husk, but still our home. And here, Its fate hangs suspended in a delicate, terrifying cosmic waltz. Will it be the third world to be consumed? The answer is one of the great, uncertain questions of our solar system's future. It is a cosmic race between two opposing forces, born from the sun's own transformation. The first force offers a chance of escape. As the sun swells into a red giant, it is also losing a tremendous amount of its mass. This happens through an increasingly powerful stellar wind. The sun is shedding its own substance, puffing its outer layers away into space. Think of it as the star becoming lighter, its gravitational grip on the remaining planets weakening. According to the laws of celestial mechanics, as a central star loses mass, its orbiting planets will slowly spiral outward into wider, safer orbits. It is as if the Earth, like a boat, is tied to an anchor that is slowly dissolving. As the anchor gets lighter, the boat drifts away. For a time, it seems this might be Earth's salvation. For every bit of mass the sun loses, the Earth drifts further away, putting more distance between itself and the approaching fire. But there is a second, competing force pulling it toward doom. Even as the Earth spirals outward, the sun's physical size is expanding much, much faster. The fiery atmosphere of the red giant is reaching out, a vast, gaseous hand. The crucial question is, will the Earth drift away fast enough to escape the grasp of that hand? Most modern models suggest it will be an impossibly close call. They predict that the Earth will drift outward to an orbit perhaps 50% larger than its current one, placing it somewhere near the current path of Mars. At the same time, the Sun will have swollen to its maximum size, its surface reaching a point just shy of this new, expanded orbit. Earth might just survive, missing engulfment by a cosmic whisker. But even this is not a guarantee of safety. A new danger emerges: tidal forces. As Earth orbits at the very edge of the Sun, the star's immense gravity will pull more strongly on the Earth's near side than its far side. This differential pull would stretch and deform the planet, flexing the rock itself, generating immense frictional heat deep within its core. And more importantly, even if the main body of the sun doesn't reach us, its atmosphere will. Earth would be flying through the sun's tenuous outer layers, the corona, which would be far denser and hotter than it is today. Moving at over 100,000 kilometers an hour, plowing through this gas however thin creates drag. A relentless, cosmic friction that bleeds away the planet's orbital energy, day after day, year after year. This drag would work against the outward push of mass loss, causing the Earth's orbit to once again decay. So we are left with this breathtaking, uncertain image. A race in slow motion playing out over millions of years. The sun's weakening gravity pushes the Earth away. The sun's expanding atmosphere reaches out and pulls the Earth back in. Who wins? We do not know for sure. It may be that our planet's final fate is to be arrested in its outward drift, to be caught at the last moment, and to slowly, inevitably, spiral into the sun, following Mercury and Venus into a fiery oblivion. Let your mind rest on this precipice of possibility. Imagine standing on the night side of this future Earth. Looking up, the sky is not black. The entire celestial dome is filled with the surface of the sun, a colossal, churning wall of deep red fire. It is not rising or setting. It is simply there, a permanent, terrifying, and beautiful ceiling of light. The ground beneath your feet glows a dull red, heated to the melting point, and you wait, in the silent space between moments, to see if the world will fall into that fire, or if it will be granted a final, lonely reprieve at the edge of Armageddon. Section 6. The Ghost of a Molten World. We left our world on a precipice, its future hanging by the finest of gravitational threads. It is a cosmic question suspended in time. Would the Earth drift away to safety, or would it be caught in the final, fiery breath of its star? The calculations are so close, the margins so thin, that for now, let us imagine the fate that is perhaps the more poignant. Let us imagine that the Earth survives, but only just. It wins the race, but the finish line is at the very gates of hell. It is not consumed, but it is captured, destined to spend the rest of its days as a prisoner, orbiting at the very edge of the sun's incandescent atmosphere. Let your mind paint a picture of this new reality. The Earth is now a tidally locked world. Like our moon, it has been forced into a captured rotation, with one side perpetually facing the star and the other perpetually facing the cold dark of space. There is no longer a day or a night. There is the day side and the night side, two eternal, unchanging hemispheres. Let us first drift to the day side. Here, the concept of a sky has vanished. The entire dome of the heavens is filled with the surface of the sun. It is not just bright. It is the source of all brightness, a permanent, colossal wall of roiling, crimson fire. It is a landscape of slow-motion explosions, of plasma currents churning in patterns larger than the Earth itself. It is a terrifying, mesmerizing, and achingly beautiful sight, the very forge of the cosmos brought to your doorstep. The light here is absolute, casting no shadows. Under this constant, overwhelming gaze, the surface of the Earth has surrendered. The fever dream of 1 billion years ago was just a prelude. The rock itself has now succumbed. The temperature on this side of the planet is thousands of degrees. The ancient continents, the bedrock of our world, have lost all memory of their form. They have softened, slumped, and melted. The great mountain ranges, the Himalayas, the Andes, the Rockies, which were once the jagged spine of our world, have flowed like warm wax, their proud peaks dissolving into a smooth, featureless surface. The entire day side of the planet is now a global ocean of magma, a sea of liquid rock, glowing with its own intense, orange-white heat, mirroring the red giant that looms above it. Convection currents, slow and thick, stir this molten sea. Plumes of silicate vapor rise from its surface, instantly swept away by the solar wind. The planet is bleeding its very stone into space. There is no sound, for the atmosphere was stripped away eons ago. There is only a profound, vibrating silence, the stillness of a world being unmade under the sheer power of another. Now let us drift around to the night side. Here, the great star is forever hidden below the horizon. The sky is a perfect, star-dusted black, more brilliant and clear than any sky a human has ever seen. The Milky Way would stretch from horizon to horizon, a river of diamonds untroubled by any atmospheric haze. But the ground beneath you would not be dark. The heat from the dayside, conducted through the body of the planet and radiating from the molten rock, would cause the entire nightside landscape to glow. It would be a dim, deep cherry red, a world lit from within. It is a land of permanent, dusky twilight, under a canopy of brilliant, silent stars. Here on the cooler night side, the magma ocean might even form a thin, fragile crust, a dark, glassy shell of cooling rock floating on the molten sea below. But this crust would be ephemeral. Asteroid impacts, or great upwellings of magma from below, would constantly shatter it, revealing the glowing furnace underneath. The surface would be a shifting mosaic of dark, solid plates and bright, fiery cracks, a stained glass window into the planet's molten heart. Whether on the day side or the night side, the Earth is no longer a planet of geology. It is a planet of fluid dynamics. It has been returned to its most primordial state, a sphere of liquid rock, indistinguishable from the protoplanets that first formed in the solar nebula. The heavy elements, the iron and nickel that once made up its solid core, are now just a denser, sinking fluid within the larger sphere of liquid silicate. The memory of a crust, a mantle, and a core is fading, the layers bleeding into one another. It is the ghost of a world, a memory of a planet, haunting the edge of its own star. And what if the race was lost? What if the Earth's outward drift was not enough, and the tidal drag of the sun's atmosphere began to pull it in? The end would be a slow, final spiral. The magma ocean of the dayside would be the first to meet the plasma ocean of the sun. The distinction between planet and star would blur, then disappear entirely. The Earth would merge with its parent, its substance dissolving into the great convective currents of the red giant. The iron that once formed the core of our world would sink deep into the star. The silicon from our mountains, the oxygen from our ancient oceans, all the atoms that once made up our home, would be scattered throughout the sun's vast interior. They would be heated, ionized, and carried in the star's currents, rising to the surface and sinking again over thousands of years. The Earth would not be destroyed, so much as it would be assimilated. It would become part of the star, a final, intimate act of cosmic recycling. The child returning to the parent, its life and legacy feeding the star for its final, glorious acts. Whether it is vaporized or simply melted into a timeless, orbiting ember, the Earth's story as a distinct world comes to an end here. It is a silent, profound transformation, a world undone by the same laws of physics that created it. But this state, this magnificent, terrifying red giant phase of the sun, is itself only a temporary chapter. Deep within the star, in that collapsing, inert helium core, the pressure and temperature have been climbing, building towards a new and even more dramatic event. The ghost of a world may be a silent witness, but the sun's heart is about to beat for a second time, in a flash of fury that will once again change everything. Section 7. The sun's second heartbeat. For millions of years, the solar system has existed in this state of magnificent, terrible grandeur. The sun, a vast, crimson giant. The Earth, a molten, captive ghost. It seems like a final, stable tableau, a portrait of an aged star and its last surviving child. But the true drama has been unfolding in secret, deep within the star's core, a place shielded from all sight by 1,000,000 kilometers of incandescent plasma. The red giant phase is not an ending. It is a fever, and that fever is about to break in a cataclysm of unimaginable violence. Let us journey back to the heart of the sun. It is a sphere of pure helium ash, crushed by gravity into a state of matter so bizarre it defies all earthly intuition. The electrons have been stripped from their helium atoms and are squeezed together so tightly that they can be squeezed no more. They have entered a quantum state called electron degeneracy. Think of it not as a gas, but as a perfect crystalline lattice of pure pressure. The electrons are locked in place, shoulder to shoulder, providing a powerful structural resistance to gravity's crush. This is what holds the core up. But this state of being has a strange and fatal flaw. A normal gas, when heated, expands and cools itself down. It has a built-in thermostat. But this degenerate core does not. The structure is rigid. Its pressure comes from the quantum crowding of electrons, not from heat. So, as the hydrogen-burning shell above it continues to pour heat down onto the core just gets hotter and hotter and hotter. Cannot expand to cool off. The thermostat is broken. The temperature climbs relentlessly, 50 million degrees, 80 million, 90 million. It is approaching the threshold of a new kind of fire, the point where helium itself can be forced to fuse. This is a far more difficult alchemy than fusing hydrogen. It requires 3 helium nuclei to collide at almost the same instant. Astronomers call it the triple alpha process. Imagine the scene in the core. 2 helium nuclei or alpha particles are slammed together. For a fleeting, impossibly short moment less than a trillionth of a second they stick together, forming a nucleus of beryllium-8. But this beryllium is profoundly unstable. It is a ghost of an element, a momentary bridge that disintegrates almost as soon as it forms. For fusion to succeed, a third helium nucleus must strike this ghostly bridge during its fleeting existence. For millions of years, this has been too improbable. But now, at 100 million degrees, in a core packed to unimaginable density, the impossible becomes inevitable. In one tiny region of the core, it happens. Two helium nuclei fuse, and before their unstable union can decay, a third one strikes home. They merge. In that instant, a stable nucleus of carbon is born, and in the process, a small puff of energy is released. A new fire is lit. And because the thermostat is broken, this is where the cataclysm begins. That first puff of energy heats the surrounding degenerate matter. A hotter core means the helium nuclei move faster, colliding more often and more violently. The rate of fusion skyrockets. This, in turn, releases a torrent of new energy, which heats the core even further. It is the ultimate runaway reaction, a feedback loop of unimaginable power. Within a few seconds, a wave of thermonuclear fire sweeps through the entire degenerate core. It is an event of breathtaking violence, known as the helium flash. For a few brief moments, the energy being generated in the Sun's core rivals the energy output of all the stars in the Milky Way galaxy combined. It is a silent, internal thunderclap, a detonation of cosmic proportions, happening deep within the star, completely hidden from the outside universe. It is the Sun's second, secret heartbeat. This immense flood of energy does what heat alone could not. It shatters the quantum structure of the core. The degeneracy is broken. The electrons are freed from their rigid lattice. The core is suddenly a normal thermal gas again, and it can finally do what it has been trying to do for millions of years. It expands. Violently, the helium heart of the Sun, once a tiny, dense cinder, now swells into a vast, stable furnace, calmly and steadily fusing helium into carbon and oxygen. This internal revolution has profound consequences for the star as a whole. The now expanded helium core pushes outward, shoving the hydrogen-burning shell that surrounds it into a larger, cooler region. This cools the hydrogen shell down, and its furious rate of fusion slows dramatically. The overwhelming torrent of energy that was bloating the Sun into a red giant is suddenly choked off at the source. The entire star responds. With its main energy source now throttled back, the Sun's bloated outer layers no longer have the pressure to hold themselves up against gravity. The great expansion reverses. The Sun begins to shrink. From your vantage point, orbiting the molten Earth, you would witness a strange and wonderful retreat. The colossal red wall of fire that filled the sky begins to pull back. Over thousands of years, the Sun contracts. It shrinks from its terrifying, world-filling size down to a much more modest sphere, perhaps only 10 to 20 times its original size. And as it shrinks, its surface gets hotter again. The energy from the new helium-burning core, though less than the peak of the red giant phase, is now concentrated on a much smaller surface area. The Sun's color shifts, climbing back up the spectrum from red, through orange, and settling into a stable, bright yellow. The Sun has found a new equilibrium. It is smaller, hotter, and, paradoxically, less luminous than it was at its red giant peak. It has entered a new, stable phase of life, a sort of stellar middle-age redux. It is now a horizontal branch star, peacefully burning helium in its core and hydrogen in a shell around it. For the ghost of the Earth, this is a reprieve. The star has receded. The intense, direct heat lessens. The magma ocean on the dayside might even begin to cool, to form a more permanent, thicker crust. The solar system is reconfigured, quieter, more stable. The Sun's heart attack is over. It has survived, settling into a calm, predictable new life. But this peace, like all stellar peace, is temporary. The helium in its core, like the hydrogen before it, is a finite fuel. This second life will be a short one, a mere 100 million years. And when this new fuel runs low, the sun will begin its final, most spectacular transformation. The cosmic butterfly is waiting in its chrysalis, preparing to unfurl. Section 8. The cosmic butterfly unfurls. The solar system has found a new, strange quiet. 100 million years of calm have passed, a brief golden age for a star in its second life. From the crusted-over surface of the molten Earth, the sun appears as a brilliant, distant, yellow star larger and hotter than the one you know, but a familiar stellar point of light nonetheless. The red terror has receded. This is a time of respite, a gentle pause in the cosmic drama. But it is an illusion of peace. The star's new helium-burning heart has been beating steadily, but the fuel for this second life is running low. The final, most glorious, and most chaotic act is about to begin. Let your mind drift once more into the star's core. The helium fusion that has defined this era has been creating a new kind of ash. As 3 helium nuclei fuse, they form carbon. Some of this carbon captures another helium nucleus, becoming oxygen. Deep in the sun's center, a new core is forming, a dense, growing sphere of carbon and oxygen. And just like the helium before it, this new ash is inert. Under the conditions in our sun, carbon and oxygen cannot be fused into heavier elements. The fire at the very center of the sun has gone out, this time for good. Gravity, the patient architect of stellar destinies, takes over once again. The carbon-oxygen core, with no energy of its own to resist, begins to collapse under its own weight, becoming another sphere of fantastically dense, degenerate matter. A dead heart inside a dying star. But the star is not dead yet. The immense heat radiating from this collapsing carbon-oxygen core ignites the layer of unused helium that surrounds it. A new fire begins, a furious shell of helium fusion. But this is not the only fire. The intense energy from this new helium shell radiates outward, heating the dormant shell of hydrogen that lies above it. That hydrogen shell reignites, with even greater ferocity than before. The sun has now developed a fantastically complex and unstable structure, like a nested set of cosmic flames. At its center is the inert carbon-oxygen core. Around that, a shell of furiously burning helium, and around that, a second shell of furiously burning hydrogen. It is a double furnace, an engine of immense power and profound instability, driving the star into its final phase of life. Astronomers call this the asymptotic giant branch, or AGB phase. It is the sun's last, grand flourish. The energy pouring out from these 2 concentric shells is simply overwhelming. It is far greater than anything the star has produced before. In response, the sun's outer layers begin to swell once more. This is the second great expansion. It is a slow, majestic, and unstoppable unfurling. The star that had shrunk back to a semblance of normalcy now begins to bloat again, reaching sizes that dwarf even its first red giant phase. From the surface of the silent Earth, the horror returns, but on a scale that defies imagination. The sky, which had returned to a familiar black, begins to fill once more with a red, growing orb. The sun swells past its previous limits, its crimson atmosphere stretching out, swallowing the orbit where Mars once danced. The Earth, even in its expanded orbit, is now once again perilously close to the surface of its star, a captive world tethered to a monster. The magma ocean, which had begun to crust over, is remelted, its surface once again a glowing liquid sea. But this time, the expansion is not smooth or stable. The double-shell furnace is a chaotic, sputtering engine. The two fires interfere with each other in a rhythmic cycle of violence known as thermal pulses. It happens like this. The outer hydrogen shell burns, producing helium ash that rains down onto the shell below. This helium builds up, getting hotter and denser, until it suddenly ignites in a runaway flash, a miniature version of the great helium flash that ended the first red giant phase. This pulse of energy from the helium shell is so powerful that it violently pushes the entire star outward, temporarily blowing out the hydrogen fire above it. For a few thousand years, the sun shudders, expands, and then, with its main power source briefly cut, it shrinks and dims. Eventually, the hydrogen shell settles back down, reignites, and the cycle begins anew, repeating every 100,000 years or so. The sun is now a pulsating giant, a star with a faltering, convulsive heartbeat. Each of these thermal pulses is a titanic shudder, a wave of force that ripples through the sun's bloated outer layers. These layers are now so vast and tenuous that the sun's gravity can barely hold onto them. They are like a fine mist waiting for a breeze. The thermal pulses are that breeze. Each pulse is a powerful shove, pushing great clouds of the sun's atmosphere away, casting them off into the blackness of space. The sun is beginning to come apart, not in an explosion, but in a series of gentle, rhythmic puffs. It is shedding its skin, layer by layer, like a cosmic serpent. With each pulse, a shell of gas, trillions of tons of hydrogen and helium, is pushed away, expanding out into the solar system as a vast, ghostly smoke ring. And within this gas is something new and wonderful. Deep in the star's interior, the helium burning has created vast quantities of carbon. The violent convection caused by the thermal pulses dredges this newly forged carbon up from the depths and mixes it into the sun's outer layers. So, when these layers are puffed away, they are rich with this precious element. As this carbon-rich gas expands and cools in the emptiness of space, the carbon atoms begin to stick together, condensing into tiny, dark grains of graphite and silicon carbide. It is cosmic soot. Imagine the view. The sun is a vast, throbbing, deep red giant, and surrounding it, like a series of nested, ghostly shrouds, are the expanding shells of gas it has already cast off. And within these shells, for the first time, is dust. A fine, dark dust that begins to obscure the light of the star behind it. This is the unfurling of the cosmic butterfly. The star is casting off its cocoon of gas and dust, the very raw materials from which it was born, now enriched with the new elements it has forged in its heart. It is not just a death. It is a final, profound act of creation. The sun is seeding the space around it with the building blocks of future worlds, future life. The carbon in your body, the silicon in the rocks beneath your feet, it was all forged in the heart of a dying star like this one, and scattered into the cosmos in just this way. The sun is preparing its legacy, a gift of stardust to the galaxy. The great, beautiful nebula is about to be born. Section 9. A legacy of stardust. The sun is now a phantom of its former self, a throbbing, unstable giant wrapped in a shroud of its own making. Its final, convulsive pulses have pushed the last of its great atmosphere away, casting it off in a final, profound act of surrender. It is not an act of violence, but of release. A final, deep sigh that sends the last vestiges of its gaseous body drifting out into the solar system. The process of dissolution is complete. The cosmic butterfly has been fully unfurled from its chrysalis. And in the center of it all, a new object is revealed. The star's core, once hidden beneath 1,000,000 kilometers of churning plasma, is now laid bare to the universe. What remains is a tiny, intensely hot, and incredibly dense sphere. It is the carbon-oxygen heart of the star, the degenerate cinder that can burn no more. This is the stellar corpse, the object that will soon be known as a white dwarf. But it is not yet white, and it is certainly not dim. At this moment of its birth, it is a furious, naked furnace, with a surface temperature of over 100,000 degrees. It no longer produces new energy, but it blazes with the immense residual heat of its long life, a final, brilliant fever before the long cool down. And this heat is unleashed upon the universe as a torrent of high-energy ultraviolet radiation. This is the moment of illumination, the moment a star's death becomes a masterpiece. The shells of gas and dust that the sun has been shedding for millennia are now drifting outward, forming a vast, expanding cloud that envelopes the entire solar system. And into this cloud, the newborn white dwarf pours its fierce ultraviolet light. This light is an artist's brush, and the cloud of gas is its canvas. The ultraviolet photons are invisible to our eyes, but they are incredibly energetic. As they strike the atoms of hydrogen, helium, and oxygen in the expanding cloud, they do something magical. They energize them, kicking their electrons into higher, more excited states. It is like plucking the strings of a trillion cosmic harps. But these atoms cannot hold this extra energy for long. Almost immediately, they relax, their electrons cascading back down to their natural states. And as they do, they release that borrowed energy, not as ultraviolet light, but as visible light of specific brilliant colors. The nebula begins to glow, lit from within by the dying heart of the star that created it. This process is called fluorescence, the same principle that makes a neon sign glow, but painted on a canvas trillions of kilometers wide. Each element sings in its own unique color. The vast clouds of hydrogen, the most abundant element, are energized and glow in a deep, beautiful, signature shade of red. Oxygen, forged in the helium-burning shell, responds to the light by shining in ethereal shades of green and haunting blues. Helium and nitrogen add their own hues of pink and pale orange. The solar system is now immersed in a celestial cathedral of stained glass, a kaleidoscope of unimaginable beauty. From the molten surface of the Earth, the view would be the most sublime and immersive experience imaginable. You are not looking at the nebula, you are inside it. The entire sky, in every direction, is a tapestry of soft, glowing color. Wisps of crimson hydrogen drift past, interwoven with shimmering veils of aquamarine oxygen. The darkness of space is gone, replaced by a luminous, multicolored fog. The light is soft, diffuse, and ever-changing as the shells of gas expand and interact with one another. And these interactions are what give the nebula its breathtaking shape. It is not just a uniform, spherical cloud. It is a sculpture, shaped by the history of the star's death. The fast, powerful wind of particles streaming from the hot white dwarf acts like a cosmic snowplow, crashing into the slower-moving shells of gas that were ejected earlier. This collision creates vast, intricate shockwaves, luminous rings, and delicate, filamentary structures. The star's own slow rotation, and the ghost of its magnetic field, stretch and twist the expanding gas, pulling it into complex, bipolar shapes, like the wings of a butterfly or the two great lobes of an hourglass. The dense clouds of carbon dust, the cosmic soot forged in the star's final pulses, create dark lanes and shadows, giving the nebula a sense of depth and mystery. We see these shapes today when we look through our telescopes at other dying stars, the Ring Nebula, the Dumbbell Nebula, the exquisite cat's eye, each one a unique portrait of a star's final moments. Our sun will paint its own, unique masterpiece in the sky. This is the sun's great legacy, not the barren rock of Earth, but this magnificent, fleeting structure of light and color. It is a monument that will last for only a brief flicker of cosmic time, perhaps 10 to 20,000 years. On the scale of the universe, it is as ephemeral as a sunset. As the gas continues to expand, it will thin out, becoming too diffuse to catch the light of the central star. The colors will fade. The beautiful ghost will slowly dissolve back into the interstellar medium, the vast, empty spaces between the stars. But its journey is not over. It has become a gift. This cloud is now enriched with the carbon, oxygen, and nitrogen forged in the sun's heart and dredged up in its final throes. These are the elements of life. This cloud, this legacy of stardust, will drift through the galaxy for eons, until one day, its journey may end as it mixes with another great cloud of gas and dust. Pulled together by gravity, it will collapse, giving birth to a new generation of stars, and perhaps new planets. And on one of those future planets, the carbon from our sun might become the basis for a leaf or a cell, or a thinking being who will one day look up at its own star and wonder where it all came from. The story of our sun ends so that other stories may begin. Section 10. The Fading Cosmic Ember. The great luminous ghost is gone. The last veils of the planetary nebula, the sun's beautiful, fleeting masterpiece, have now expanded so far into the void that their colors have faded into the black. They have dissolved, a soft whisper of gas and dust now beginning its long, silent journey to see distant corners of the galaxy. The solar system is empty again. The celestial cathedral has been dismantled, leaving only the altar light burning at its center. And the molten earth, a silent parishioner, now orbits the strange new star. What is left is the sun's final, naked self. A white dwarf. It is a name that feels too plain for such an extraordinary object. Imagine it, the entire mass of a star, compressed into a sphere no larger than the Earth. It is a cosmic diamond, forged in the heart of a giant, now left to cool on the black velvet of space. Its substance is so dense that a single teaspoon of it would weigh many tons on Earth. It is a monument to gravity's final, crushing victory. This tiny star, this stellar remnant, blazes with a fierce, initial light. It is no longer the gentle yellow of a gardener or the angry red of a giant. It shines with a brilliant, piercing, blue-white light, the color of an arc welder's torch. It is the light of pure, unadulterated heat. From the surface of the frozen earth, this new sun would be a single, dazzling point in the sky, a pinprick of searing intensity that would cast sharp, black shadows across the solidified plains of rock. And now, the longest, quietest, and most profound process of all begins. The cooling. The white dwarf has no internal fire. It has no more fuel to burn. It is like a cannonball pulled from a forge, and all it can do now is slowly, inexorably, radiate its stored heat away into the endless night. This is the sun's long goodbye, a farewell that will last for a timescale so immense it makes the entire past age of the universe seem like a brief morning. Over billions of years, the white dwarf begins its slow journey down the color spectrum. The fierce, blue-white light softens, mellowing into a brilliant, pure white. The tiny, dazzling star still shines brightly in the sky of the frozen earth. Billions more years pass. The universe itself is aging, the great galaxies flying further apart. The white dwarf continues to cool, its light now shifting to a soft, familiar yellow. It is a ghost of the sun we once knew, a final, faint echo of the star that once nurtured life. More time passes than the mind can hold. Trillions of years. An eternity. The universe is now ancient, cold, and dark. Its stars long since burned out. And our sun's remnant continues its slow fade. Its color shifts from yellow to a warm, gentle orange, and then finally to a deep, dusky red. It is a single, dying ember in a cosmic hearth that has long since gone cold. It barely illuminates the frozen face of the Earth, which glides on in its eternal, silent orbit. And then, after a span of time that is truly unimaginable, the last of the heat is gone. The final photon is radiated away into the void. The light goes out. The ember ceases to glow. The star is no longer a star. It has become a black dwarf, a cold, invisible sphere of carbon and oxygen, utterly dark, its temperature now matching the near absolute zero chill of the background universe. It is a ghost in a cosmic graveyard, detectable only by the silent tug of its gravity on the frozen planets that still, faithfully, circle it in the darkness. There is no light. There is no heat. There is only a profound and everlasting silence. The sun's story is over. Our long journey through time is complete. We have traveled from the warm, stable light of the present day, through the fiery trials of a dying star, to the final, quiet peace of the cold and the dark. We have witnessed the fate of our world and the ultimate destiny of our sun. The great cosmic drama has ended in stillness. Let the scale of that immense, slow story wash over you now. Feel the final, profound silence of that future solar system. It is a silence that holds no fear, only a deep and final peace. A peace that can now settle over you, here in the warmth and comfort of your bed. The universe's great cycles of fire and fury have faded to black, and so too can the thoughts and worries of your day now fade into a quiet, comfortable darkness. The story is finished. There is only rest. And now, as you drift into that peaceful space, I wish you a deep and restorative sleep. Good night.